A train is moving at a constant speed of 90 km per hour on a straight level track. From a railway station P on the track, there is a village Q at a distance 1.2 km in a direction perpendicular to the track. When the engine E is 1.6 km away from the station, the driver honks a beep of horn of duration 44 seconds. Calculate durations heard at the station and in the village. The speed of sound is 350 meter per second. So there is a station P, a village Q is there. This is railway track on which this train is moving in this direction, and it's given that when train is at a distance of 1.6 kilometer from the station, so that is 1.6 kilometer, that is 1600 meter. So when the engine of train is 1600 meter from the station, it honks a beep. Okay, so at this position, a beep is being honked, is continued for a duration of 44 seconds. It means while these 44 seconds, this train will continue to move, and it will move a distance equal to 44 into the speed of train. The speed of train is 90 kilometer per hour. Convert it into meter per second, so that will come out 25 meter per second. And if you multiply these two, so it will come out 1100 meter. So during that honking of beep, the train will move by 1100 meter. So when at the end of beep, the engine of train will be somewhere here at E dash. Now we have to find what time will the beep be heard at P and at Q, the duration of time of beep. So that we have to find. Okay, so first we are finding for P. So this is train, this point is P, this is the start of beep. At the starting of beep, suppose time is 0, and the start of beep, the initial beep will take some time to reach at P, and when it just reaches P, suppose the time is T1, so T1 will be equal to this distance, which is 1600 meter, divided by the speed of sound in air, that is 350. Okay, now the train is continuing the beep up to E dash. Now the beep is ending at E dash, so that end of beep will also reach the point P at time, suppose T2. So the engine stops beeping at t equal to 44. So that beep, the end of beep, that is emitted at t equal to 44, and that will take a time to reach P. And since this distance is 1600 minus 1100, this we have found here, 1600, this is 1100. So the distance left is now 500. So the end of beep, the ending part of beep will reach at P at the time 44 plus 500 divided by 350. So at this time, T2 time, the end part of beep will reach at P. At T1 time, the initial part of beep will reach at P. So the time duration for which the beep is reaching at P is the difference of T2 and T1. So So this is the time interval for which beep will be heard at station P. And if we solve this, it's coming out 42 seconds. Okay, so this is first part. Now we have to solve the same thing for this village Q. Now this village Q is initially at a distance of this distance is this is 1200, it's given. This is 1600. Then using Pythagoras theorem, this distance will come out 2000 meter. And from E dash, this distance will be equal to, since it is 500, so this will be 1300. Okay, the same calculation is to be done for point Q. The starting part of beep will reach Q, covering a distance of 2000 meter with a speed of 350 meter per second. So this is the time when starting part of beep reaches Q. The end part of beep, it is emitted at t equal to 44 seconds, and then it will cover 1300 meter to reach to Q. So this is the time when end part of beep is reaching Q. So the duration for which the beep is heard at Q will be T2 minus T1. So subtract these two times and solve. So we'll get the time duration during which beep will be heard at Q. Okay,